part 2, because we're having technological difficulties. All right. One of the cubes that we find commonly, one is 1,000. The other one is 8. What do you think the cube root of 8 would be? Yes, sir? 2. Because 2 times 2 is 4. 4 times 2 is 8. Okay? Yes, sir? And what is the cube root of 729? 9. There we go. Okay, so square roots and cube roots. Perfect squares, perfect cubes. Those go hand in hand. All right, I will give you a list of some perfect squares and perfect cubes. I'm not going to tell you to go home and memorize them all, but it will make things easier. Okay? Does that make sense to everybody? Okay, cool. So we know what perfect squares are. We know what perfect cubes are. The radical sign. Look at the middle of page 168. Radical sign is highlighted. And then it gives a symbol. Okay, that symbol looks kind of like a combination between the Nike swoosh and the division. Right? If we're going to do long division, it's a kind of a combination of the two. Alright, that is the radical sign. If there is nothing else with that, that means that we are going to take the square root of whatever's underneath the house. Okay? What? Not quite. We're not going to divide because we don't know what to divide by. We can't divide by 2. Right, so we have to, that's where we have to have a good understanding of our multiplication facts so that we can recognize that relationship between numbers. Okay? All right. Now, if we look at the 3 examples there, we have the square root of 36, then the negative square root of 36, and then it says plus or minus the square root of 36. All right, plus or minus the square root of 36. First of all, can we take the square root of a negative number? No, because any negative times itself would be positive, and we can't have something times itself to get a negative answer. Okay? So if the base is negative, if our root is negative, the negative sign has to be outside of the radical symbol. Everybody got that?
Yes.
Okay. Now that plus or minus symbol. Plus or minus. That means that our answer is more than one value. That means that we're looking at either the positive or the negative value. Okay? There are some people that would say that the square root of 36 is plus or minus 6, because either one's right. It just didn't specify it. The way that your book has things doing it, if it wants both values, if it wants all possible answers, it's going to give you that plus or minus symbol in front of the radical. Okay? Yes? So, they made it really easy and specified when it wants any possible answer and when it just wants the positive. Got it? Yes? Have I said positive and negative too many times? Yes? Okay. Let's look at an example. Let's look at example 1. We're going to do example 1D. No, we're not. Okay. Correction. We already kind of went over in part 1 of the video before we had technology issues. That we know, example 1A, the square root of 9 is going to be what? 3, because 3 times 3 equals 9. If we don't know our multiplication facts well, is that going to be more difficult? Yes. Okay. Example B, the negative square root of 64. What's the square root of 64?
8.
8. Make it negative?
Negative 8.
Negative 8. C, the plus or minus the square root of 4. What's the square root of 4? 2. Right, plus or minus 2. Okay. Now here's what we were just talking about. In example D, can we take the square root of negative 81? No. There is no solution. So, could our answer be no solution? Yeah. If the solution doesn't exist, that's still an answer. Okay? Don't try to make it work if you see something that you know is impossible. We know that taking the square root of a negative number can't exist. So the answer is no solution. Okay? Alright. Now, here's the part that nobody likes about square roots. What are we going to do if we have to find the square root of a non-perfect square and I tell you that we're doing it without a calculator? Alright, the sounds need to stop. Yes, sir, what do you think we're going to do?
Estimation.
We could estimate. The directions say to estimate. But what does it say to estimate to? Okay? So, the directions say to estimate each square root to the nearest integer. Could I say estimate to the nearest tenth? Estimate to the nearest hundredth? Could I do that? Yeah, absolutely. But let's start with the nearest integer. So, if I'm asking you for the square root of 33, okay, what is the nearest perfect square? What is the perfect square nearest that is going to be less than 33?
25.
Okay, so the square root of 25 would be less. What's the square root above 33?
36.
Okay. Alright. Which is closer to 33? 36 or 25?
36.
36 is closer. Okay, so the square root of 36 is?
6.
Square root of 25 is?
5.
So the square root of 33 is going to be closer to which integer?
6.
Now, we're going to double check it. Okay? We're going to double check it. To double check, and guys, there's no real way to do this besides guess and check. We know that the square root of 33 is going to be somewhere between 5 and 6. Yes? Okay, so let's start with 5 1/2. What is 5.5 times 5.5? Let's do it. 5 times 5 is?
25.
5 times 5 is?
25.
Plus 2 is?
27.
Okay. Add a 0. 5 times 5 is?
25.
It's going to be the same thing. Add it together. 5, 2, 30.25.
So it's bigger than.
So, this square root of 33 is going to be larger than 5 1/2. What? You want to try 5.7?
Yeah.
Okay. Seven times 7 is?
49.
7 times 5 is?
35.
35 plus 4 is?
39.
Add a 0. We can take, no we can't. 5 times 7 is?
35.
Carry the 3. 5 times 5 is?
25.
Plus 3 is?
28.
Adding 9. 4. $32.49. So, to round to the nearest tenth, we would say 5.7.
Yes.
Because we're off by about half.
51. 51.01.
Hold on, what?
We're off.
Alright, which is about 0.5. Which which is about half of 1. Rounding, dear. We said to the nearest tenth, that would be 0.5. So, we can keep going until we get to the hundredths and the thousandths place, and at some point we would have to round to 33. Okay? Alright. I'll let you do it. We're going to move on to the next problem. I love how excited you guys are about math. Alright. So, do you see how we check nearest integer? Yes? Okay. Do you see how we check nearest tenth? Yes. Nearest integer, we just have to know our basic facts. To the nearest tenth, we have some guess and check to do. Okay? But going up to 5.7, we were off by 0.5. That's pretty darn close. If we went up again to 5.8, we'd be up too high. Okay? Alright. Let's look at another problem. Now, I will show you how to do this on your calculators after we get some practice without, okay? The reason we're going to do it without first, I don't know if this is going to be on the calculator or the no calculator part of our test. And we need to know how to do it without, okay? Everybody got it? Okay. Alright, look at the bottom of page 170. It says cube roots. And it tells you that a cube root is a number, the cube root of a number is one of its 3 equal factors. Then it shows you how to write it. Guys, look at the symbols part, or that radical sign. There's a little 3 in the middle of that Nike swoosh, isn't there? Okay? Nike, please don't sue me. So, that 3 means we're taking the 3rd root. Could we take the 5th root? Yeah, could we take the 8th root? Could we take the 22nd root? Yeah, we could. We're not going to, but we could. Alright? So, any number that we put in that Nike swoosh part of our radical sign tells us what root we are looking at. If there's nothing there, we're taking the square root, or the 2nd root. Okay? Everybody got it? Yes? Alright. So, let's look at example. We're going to look at example 4 and 5. Okay? Alright. Example 4. You already told me that the cube root of, no, you didn't do 343. When we look at our cube roots, that means that we're going to take a square root and multiply it by its root. Okay? So, are these things that we're going to know quite as easily? No. No, we're going to have to do a little bit more math here. And this is where, when I give you that list of cube roots, it's going to be helpful if we get a couple of them down so that we have some kind of starting point. Am I going to make you memorize them and give you a quiz saying, match each base to its root? No, I'm not going to do that.
Yeah, that wouldn't be that hard.
You want one of those?
No. Yes.
Yeah.
How about, we'll work something out, okay?
How about you do one for me and Connor?
What?
How about you do one for me and Connor?
No names, we're in video mode. And I'll think about it, okay? We'll think about it. Alright. Example A is the cube root of 343. Now, the other thing, when I write my cube roots, first of all, my radical signs always look a little bit more like U's than they do V's. Do you still know what the symbol is?
Yes.
As long as we can all tell what the symbol is, we're good. Okay? Thank you. The root, I also always write my root first, then I draw the radical. Otherwise, sometimes we don't leave enough space for the root. So I need something times itself 3 times to equal 343. Now, if we look at our book, we know that the answer is going to be 7. Do we know that that's 7 off the top of our head? No. So, I like to guess and check. The numbers that you work with should be between 0 and 12. Okay? So what's between 0 and 12? What number is about the middle between 0 and 12? 6. Okay, so I'm going to start with 6. 6 times 6 is what? 36 times 6 is? And that's why I say cubes and cube roots are difficult. What's 6 times 6?
36.
6 times 3 is? 18 plus 3 is?
200.
Okay. So, the 6, listen. So, if we know that 6 cubed is 216, does that give us a starting point? Okay, it knows that it'll tell us if we're looking for something higher than 6 or something lower than 6. 343, not that far away from 216. Okay? So, I would check 7 next. It's either going to be 7 or 8 based on how far apart the numbers are, correct? 7 times 7 is?
49.
Times 7 is?
343. Yeah.
Okay. We know that that's 343 because that's the answer in our book and the example works it out for us.
Yes. And I can do it.
What?
It's easy to do. Oh yeah, you're right.
Okay. Some people, because everybody's brain works a little bit differently, some people do really, really well with this. Other people need to do all the math. I may do all the math, people, for anything above a cube of like 4. Okay?
What?
Okay. So, if you need to do the math, do the math. If the number just kind of works its way out in your head, congratulations. I want you to show me some way that you can justify it. Okay? At least at first. Now, example 5. Example 5 says to estimate the cube root of 83 to the nearest integer, and it says do not use a calculator. Well, we could use the numbers that they did and get the answers from the book. But we're going to use a different number. So, cube root of 3 cubed is what?
27.
Cube root of, I asked the problem I wanted to ask way wrong, and I apologize. 10 cubed is 1,000, correct?
Yes.
Okay, so we're going to go some number between 0 and 1,000. Someone I have not heard from yet, if you wouldn't mind volunteering to give me a number. Yes, ma'am.
747.
747. Okay, so we know that the cube root of 1,000 is going to be somewhere up there, right? Okay. Cube root of 1,000 is 10. We know that the cube root of, we know that 6 cubed was what? 216. Is this going to be closer to 6 or closer to 10?
It's between 9 and 10.
Okay, why do you say it's between 9 and 10?
Because the cube root of 9 is 712.
You mean 9 cubed is 712? Okay, so we have someone that knows that 9 cubed is 712. Let's double check. 9 times 9 is?
It's 729. I didn't say 912.
900 what?
729.
Where did I get 912 from?
I don't know.
I don't know either. Okay,
That's a great question. That's the answer.
that's what we're double checking. 9 times 9 is?
81.
81. 81 times 9 is?
729.
Okay.
Yeah, you're right.
And the cube root of 1,000 is 10. 10 times 10 is 100. Times 10 is 1,000. All right. Is 747 closer to 729 or 1,000?
729.
So it's going to be closer to 9. It's going to be closer to 9. Okay? We could multiply 9.5 times 9.5 times 9.5 to justify, but we know that if we have some space between 729 and 1,000, 747 is closer to 729, so it's going to be closer to 9. All right. Any questions? No? All right, thank you.